All right. Hello, everyone. I'm Bernd, and today is day 5 of Edward and Code. Let's get right into the problem. So today is all about stacks. So today our input consists of two parts. The first part is the starting position of the stacks, and the second part is a few instructions that are going to happen to that. So the starting positions, we have like a few stacks numbered with like numbers 1, 2, 3, and so on. And then each stack contains a few items given by like these uppercase letters here. And then we have the second part are instructions that are going to be applied to those stacks. So for example, move one item from stack 2 to stack 1. So that would then result in this position of the stacks. Or then the next instruction is move 3 items from stack 1 to stack 3, resulting in this position. And importantly, we only move one item at a time. So D, which is in the highest in the stack 1, would then go in the lowest on stack 3, like the lowest additional item, and so on. So the order changes. And then once we have completed all the moves, we are left with a position with the stacks, and then we want to look at the top item in each stack, and then concatenate this corresponding string, and that will be our end puzzle answer. So how can we do that? So what we need, obviously we need to read the lines, so we just split the lines, which removes the empty string characters for us. And then what we want to find, we want to separate all the lines into two parts. So we want to find the empty line index, which is then enumerate through the lines. And as soon as the line is empty, we return the corresponding index. And then we want to process all the lines. So yeah, how do you do that? We first find the empty line index by the function we just defined. And then we take all these lines corresponding to the starting stacks. Also like turn them upside down in this case to make them easier to process. So we start with the in line before the empty line index -1, this index, and go all the way to the highest line, the first line of the file. And then we process those lines to get the starting stacks. We also want to have the instructions. So the lines for the moves are the lines from the empty line index +1, starting there and going to the end. And then we can also get them we want to get the moves out of those lines and process those lines. So then maybe the more complicated one is the first thing, how we process the starting stacks lines. So we just flip them upside down, change the order. So it starts with this index line, and then all the items come below. So yeah, the index line is the first line. And then what we notice, like all these letters are at the position where the 1 is, all these letters in the second stack at the position where the 2 is, and so on. So we want to find those columns corresponding to the digits. So we go through the index line, and as soon as the letter is not equal to the space, we assign the column. The integer of the letter would then be the stack number, and the column corresponding to the stack number would then be like the index in these lines. As soon as we have that, we want to define stacks. So the stacks we define as a dictionary, and we have the integer, which are like the numbers of the stacks, and each integer corresponds to a list of strings, which would be the items. At the beginning, we set all of these lists to be empty, so we have no items in any stacks. And then we go through each line in those starting stack lines. We go through the column items, which it gives us the stack number, 1, 2, 3, and the column number, which would be like corresponding to this column, or this column. We get the item corresponding to the column number. If the item is empty, we continue, and if the item is non-empty, we add it to the corresponding stack. So since that processing is a bit of complicated, we can do a little test. So we have a test input, then we can process it by hand into getting those stacks representations, and then we can run a little test to make sure that we actually get those test representations out. That looks promising. So we can go on and process the move instruction. So we define a little data class here, so that maybe just creates an initializer which those elements, so to make it nice. The move instruction is mostly there so that we don't get confused the numbers, but we know like the first number is amount. We have easy access to all these numbers. So how do we process the lines? So for each line in the line, there are 3 integer hidden somewhere. In order to not be able to like have to replace all the strings or anything, we just use regular expressions, and we find all of this form. So that's an integer, a digit, and it takes multiple digits in a row and puts them into one number or in one string. And then for each of those strings, we convert into an integer. So this gives us the 3 integers in the line, which happen to be amount, from stack number, and to stack number. And then we make a move instruction out of that and append it to the whole set of move instructions, the whole list of move instructions. Okay, so that's kind of it for the data reading part. Now the kind of more the other part of the code, or how we move stacks, or how we move items from stacks to the other. So we can have if you have a single move instruction and we want to move the items correspondingly, we just not too complicated to do. So we have first the from stacks, which is just the stack and the index from stack number. We have the to stack, which is a list, and we get it from the stacks at the to stack number. And then we want to move amount numbers, so we do this line essentially amounts times. And what we do here is we take from step and pop, so that removes the last item and also returns it. And then we can immediately append those items to the to stack. That's the main logic for processing the move instructions. And then the move items from a list to move instructions, we just go through the list of move instructions and move items corresponding to these instructions. Yeah, that's kind of the whole program. In order to solve, we process the lines, as said before, end up with a starting position of stacks and a set of moves, or a list of moves, and then for each of those, and then we move the items corresponding to those moves. And then from each stack, we take the last element and join them into one string to get our final answer. We can also run a test on this, and it does give us the result we expect or hope for. So we can also run the whole program, and it gives us the right answer. Okay, so for part 2, it's slightly different. So now we're not moving one item at a time, but we're actually moving the whole stack of items, or not the whole stack, but like if you're supposed to move 3 items, we move 3 items at the same time and add them to the stack in the same order as they were. So we can use reuse most things from part 1. What we have to change is the move item function. So there again, we have a from stack and a to stack. We get this by the move instruction, the from stack number and the to stack number. And then we can first add to the to stack all the items that's supposed to go there. We do this by extending it and just selecting the items from the stack we want to take items from, and there's like amount from the end to the end. And then we still need to delete them from the from stack, so we just iterate to this line amounts times, where I just remove the last items with pop. The rest is pretty much the same as before. And again, if we run a unit test and it gives us the right answer, so that looks promising. And if we run it on the actual input, we also get the right results, so that's nice. All right, that's it for today. Hope you enjoyed the puzzle, and best of luck for the other days. See you.